Hello, welcome to this video. If you're new to this channel, please subscribe and click the bell to get more notifications on videos that will be posted further. Today we're going to be learning about calculus, mainly finding the equation of the normal. As the question states, determine the equation of the normal to the curve y is equal to 2x squared minus 3x minus 2. That passes through the point 3, 7. And also we're going to evaluate the question that is after that, mainly tackling integration. So we are previously from reading the question, which told us to find the equation of the normal. So we're going to draw the curve. Here we are insinuating that's the curve and this is the tangent. Then the normal cuts the tangent at 90 degrees. So this is the normal. So firstly, our first step will be to derive this equation, which will be dy over dx. In this case, we're using the power rule, which says that the power has to multiply with the base, and then the power still has to reduce by 1. So it will be 2 by 2, x to the power 2 minus 1 is reducing by 1, minus 3 by 1, insinuating that x is the power 1. So x, 1 minus 1. When you derive a constant, it always gives 0. So it would be best, it should not be included here. So this is equal to, so we're going to multiply it further. So it will be 4x to the power 1, of which we won't have to include it, minus 3 times 1. So it will be 3 by 1 is 3. And then x to the power 0 is 1. So we'll have to leave it in this way. So we found the gradient function in this case. We're going to find the gradient of the tangent. Yeah, so dy dx is also the same as the gradient. So we're going to say dy over dx is equal to 4. So in this case, this is the gradient function. We're placing the x coordinate in place of x, so which is 3 minus 3. So m is going to be equal to, as we say, this is gradient. 4 by 3 is 12 minus 3. M is going to be equal to 9. So in this case, we have found the gradient of the tangent. So the tangent is here. We found the equation. So in the first place, why we said we had to know this type of interpretation was because of when we reach this stage. So in this case, we have found the gradient of the tangent and not the normal. So we can't go further before we find the gradient of the normal. So in this case, the tangent and the normal are perpendicular to each other, hence giving us this equation m1, m2 is equal to negative 1. So our first gradient is 9, then m2 is equal to negative 1. So to make m2 the subject of the formula, we're going to divide by 9. By 9, m2 is equal to negative 1 over 9. In that case, so in this way, when you end here, you know that you're almost reaching the final answer. So we'll go further into saying the equation, the formula for the equation is y is equal to mx plus c. So in this case, we've been given the coordinates which we'll have to use throughout. So our y is 7, our x is 3. So we'll replace to find the constant. So our y is 7 is equal to m. M is our gradient, 1 over 9. We'll put it in brackets for best. And then x is 3 plus c. In this case, we're finding the constant as we said. So here cancels, and then this is 3. So it will be negative 1 over 3 plus c. We're going to bring that this side, so plus 1 over 3 is equal to c. Then that is 21 plus 1 over 3c. So c is going to be equal to 22 over 3 in that case. So we have seen that we have found the constant, hence knowing that we're almost there. So now that we found our constant as 22 over 3, so then our equation is equal to y is equal to mx plus c. So firstly, in this case, for you to find the final equation, the only parts you have to replace is the gradient and the constant. So which is y is equal to, the gradient that we found was negative 1 over 9x plus the constant, which is 22/3. And this is the final answer. So the main point is replacing the constant and the gradient for the final answer. Okay, now we'll go to our second question, which says evaluate that equation here. So differentiation, or can I say integration? This sign is an integration sign. Integration is the opposite of differentiations, opposite. So can I say we can have an example 2x squared. In this case, differentiation, you multiply the power by the base. But for integration, the power increases by 1 and we divide by the new power, which is 2 plus 1, which in this case will be 2x to the power 3 over 3. That's integration. So I just wanted to give you a glimpse of what we do in integration. So in this case, as we said, we have the lower bound and the upper bound. So we'll say equal to, so we'll open a bracket and then we'll integrate all this. So with respect to x, x is obviously in the function. So we integrate, so we say x to the power 2 plus 1 over 2 plus 1 minus 2x 1, insinuating that there's a 1 there, plus 1 over 1 plus 1 minus 3x to the power, there's no power obviously because it's just come up. So mostly when integrating, the constant that doesn't have a coefficient mostly gets a coefficient because we're including it. So as we said, it's the opposite of differentiation. So after that, we add the bounds which is 1 and 0 there, insinuating that the bounds are here. So we remove the integration sign and add the bounds at the end of the brackets. So next we're going to simplify that further. So x to the power 3 over 3 minus 2x to the power 2 over 2 minus 3x. We bring the bounds there. And then we bring it down. We break it down now. So x to the power 3 over 3 minus x squared. So these cancel. So which will leave us with x squared minus 3x. And then we have the bounds. So the bounds are there to remind us that they are going to work somewhere. So further, we are going to say, in the actual sense, the upper bound subtracts the lower bound. So let me show you how we go. So we say x to the power 3 over 3 minus x to the power 2 minus 3x with the upper bound only minus x to the power 3 over 3 minus x squared minus 3x with the lower bound 0 over there. So actually, as we said, the upper bound always subtracts the lower bound, which is 0. So in this case, if we have the lower bound as 0, mainly we do not include the lower bound because obviously this is going to cancel out. It's going to give us 0. So let me show you that so that you won't argue further. So in this case, we replace the 1. So 1 to the power 3 over 3 minus 1 to the power 2 minus 3, 1 minus. So we don't include the bound because we've already replaced. The bound is not the power. It's actually meaning that we'll have to replace where x is. And then there we go. And then here we'll introduce the 0 to the power 3 to prove to you that it always gives you 0. So it's irrelevant to include it. So there we go. And then we bring it down low. So 1 to the power 3 is the same as 1 over 3 minus 1 minus 3 minus. So 0 to the power 3 is 0. 0. Everything is going to give us 0 here. I bet you now agree with me. So this is 0. So we now bring it down. So we are going to simplify this. So of course we know how to simplify this. We just do it by the side. So 1 over 3 minus 1 minus 3. So the common denominator is always 3. So 3 by 1 is 3. So there we go. Minus 3, which is going to be a negative 2, over 3 minus 3. So in that case, again, we reduce it further. This is simple grade 2 mathematics. So we have to do it. So there we go. It's 9 minus. So there is also negative 2. So when we simplify it further, we'll do it further. we say negative 11 over 3. So our final answer is negative 11 over 3.